right, so 22. Write the trigonometric expression as an algebraic expression. Okay, so it's kind of the opposite of what we just did, where we went from like a bunch of x's, we turned it into some trig. Here, we're gonna turn this trig into like an equation with some x's, or an expression with some x's. Okay, so first things first, I see sine of, let's see, sine of two things being subtracted. Let's see here, is that one of my little identities here? I think we had an identity for that. Let's look, sine of two things being subtracted. Where are we at here? Okay, here we go. I'm thinking we're gonna use this one, sine of u minus v. Okay, the u being this messy arctangent of 6x, and the v that I was subtracting is that messy arc cosine of x. But I found the identity I was going for. Sine of two things being subtracted. I labeled the u and the v, and I'm gonna put this into the other side of the equation, my sine of u, so sine of the arctangent 6x, okay, cosine of v, which my v is arc cosine of x, all right, and then minus cosine of u, which my u was arctangent 6x. And sine v. So sine of my v was the arc cosine of x. Okay, it looks long, but what I'm noticing is I've got a cosine and arc cosine. I got like inverses going on there. So that turns out to be just a plain x. I also have, let's see, were there any more of those? I don't think any more of them just like straight up canceled out. There's just that cosine and arc cosine. But let's see, I also have a triangle. Should we put together a triangle? Let's do one for the u. We'll do a separate triangle for the u and a separate triangle for the v. So for the u, I've got, here's my right triangle here. Here's my u. It said arctangent of 6x, and tangent is opposite over adjacent, right? Okay, and it was like a 6x. You can treat it like 6x over 1 if you want to treat it that way. But there's my opposite over adjacent. So all right, I'm gonna do some Pythagorean theorem and find that missing side. Once I have all three sides on this triangle, I can do whatever trig function they want of u. So let's see, Pythagorean theorem, 6x all squared plus the 1 squared equals the c squared. All right, so 6x all squared, that's where I'm at here, 36x squared plus 1 equals my c squared. I'll take the messy square root of 36x squared plus 1. There's my c side here. Okay. But I've got the whole triangle. Any questions on my triangle? So you guys can take this arctangent of 6x and you can turn that into its triangle. Can we do that? Because if I have that triangle, I can find I can find any trig function of u. They wanted, in fact, here, they wanted sine of this arctangent 6x. Again, this is like my u. Arctangent 6x is my u. They want sine of that. And the sine of that u, so katoa, sine is the opposite over hypotenuse. So the sine is the opposite of the 6x over the hypotenuse, that messy square root that we found out. Whew. Okay, any questions on how I got this fraction? Or questions so far at all? You guys online, how we doing? All right, we're doing good so far, okay. Nice. All right, so if we're good with this fraction so far, and it's multiplied by that x, because of my cosine and arc cosine, those are inverses. I got down to a plain x. Okay, minus. I've got that arc tangent of 6x again. I got like my u here again. They want cosine of that. Cosine off of this triangle, cosine the adjacent over hypotenuse, that's going to be my 1 over square root of 36x squared plus 1. There's my adjacent over hypotenuse. All right, it's messy, but I like that they have a common denominator. All right, sine of arc cosine x. We don't have a triangle for that quite yet. Let's see here. My arc cosine, I'm gonna do another right triangle here. That was like my v, the arc cosine of x. Cosine though, cosine is adjacent over hypotenuse. And it's an arc cosine of x, so my adjacent is the x, my hypotenuse is the 1. It's kind of like x over 1. There's my adjacent over hypotenuse. What were you saying?
So the 1 came from the...
From the x. It's like x over 1. If I'm looking at it as a fraction to see like adjacent over hypotenuse, I'm going to treat that x as like an x over 1. My adjacent is the x, the hypotenuse is the 1. Is that better? Okay, so then I do need to find this missing side still. So I'm gonna do some Pythagorean theorem on this again. A squared plus b squared equals c squared. So I gotta find that b side here. Let's subtract my x squared over and then take a square root. So this b is the square root of 1 minus x squared. Okay, they wanted sine of this RV angle that we labeled, the arc cosine of x. They want sine of that. Sine is opposite over hypotenuse. So it's going to be my square root of 1 minus x squared, like over 1, basically. Okay, any questions on this triangle or anything I've done so far? At this point, I just have to simplify. This is all straight up x's now. In fact, they have common denominators. Like both of them have that messy square root of 36x squared plus 1 denominator. The numerator, let's see, I've got a 6x times x, like a 6x squared, minus, and 1 times this messy square root is just the square root. So it's a square root of 1 minus x squared. Okay, so here is my final answer. Let's see, is that what they got? 6x squared minus the square root of 1 minus x squared, okay? All over my square root of 36x squared plus 1. Okay, so it's the same thing they got. I found the identity in this sheet, first things first, and then I used my triangles to help me turn the trig into some algebraic expressions. All right, any questions on number 22? No, we're good? Okay, 23. Find all solutions of the equation in the interval 0 to 2 pi. Okay, so I'm not going to put like a, remember how we do like a plus pi n, or like if it was rotating like over and over and over, you're going to hit the same spot. We would have like some n in there. But we're not looking for every possible solution. We're looking at the answers from 0 to 2 pi, like on one rotation around my unit circle. All right, so let's see, find all these solutions. I do notice right off the bat, I saw sine of x plus pi halves. And I think we have an identity. That blue one that I highlighted was sine of u minus v, but this is sine of x plus. I've got two things added. Let's see. I think I'm going to go with. Let's see. I think I'm going to go with this identity, sine of two things added together. Okay, but I found the identity on my sheets. Let's identify the u and the v, and then we'll use the formula for that, the identity for that. Okay, so it looks like my u is the x and my v is the pi halves. So if I use my identity here, I get sine of u, which my u is x, cosine of v, which the v is pi halves, plus cosine of u, so cosine of x, times sine of v, so sine of pi halves. Okay, so I use the identity on this guy. I still have the whole, minus cosine squared x equals 0. I put it in black like it was the stuff they gave me to begin with. All right, the blue stuff was that identity. Any questions so far? We're good? Okay. We're good? Well, then what I'm going to do is, let's try to simplify this down. Like I got some actual angles in there, pi halves. What's the cosine of pi halves? We should have memorized the unit circle. I gave you a sheet of identities for the test, but I'm not giving you the unit circle for the test. You do have to memorize the unit circle. Okay. Yeah. What was that? 0. Cosine of pi halves is 0. Nice. So really 0 times all of that, 0, bam, gone. That's kind of nice. What's sine of pi halves? 1, which I can multiply by 1 all day long. It's not going to change this. It's still going to be a cosine of x. Do I really need to put times 1? I'll just leave it cosine of x. And then I've got minus cosine squared of x equals 0. All right. Let's see. I'm going to factor out my cosine. I factored it out, and I can set my individual factors equal to 0. So if I set my cosine equal to 0, and I'm going to set my 1 minus cosine equal to 0. All right, cosine is 0 on my unit circle. Cosine, like the x values, are 0, like at these two spots. So that's at what, pi halves and 3 pi halves. Okay, all right. This one, if I solve here, if I add the cosine over, 1 equals cosine of x. So my cosine, again, my x values on my unit circle, cosine of x values, and my cosine over my x values are a positive 1, like over here. Is that a 0 or a 2 pi? What am I going to treat it as? Let's see. They said the square bracket here, like include the 0, but they've got parentheses on the 2 pi. I'm not going to include the 2 pi. So out of the 0 or the 2 pi on my unit circle here, I think I'm going to call it 0. I'm going to include the 0. I'm not going to include the 2 pi. So it looks like I got 3 solutions here. Look at this, 0, pi halves, 3 pi halves. Those are the solutions that I found on my unit circle. Okay, any questions on, what is this, number 23? You guys have any questions on 23? That blue part was the identity. You guys gotta be able to find the identity on the sheet here. Okay. Nice, Audrey. Okay, what?
On 22.
Uh-huh.
The only difference from mine was for the 6, I had a 7.
Okay, so very similar.
Yeah, but I still got it wrong.
I'll have to check that out in a sec here. All right, nice, Justin. All right, so I'm gonna go to 24 then. 24 also says find all the solutions on the intervals 0 to 2 pi. So I'm not gonna have like, the repeating solutions over and over again. I'm just gonna get a set amount of solutions. That's it. So it says solve the equation. All right, so what is this? 2 sine of 2x. I have that one. Plus 2 cosine of 2x all squared equals 4. I think I did that one, actually. I didn't do that one. Okay. Does this look like an identity to anybody right off the bat? No, which one? Oh, the double angle formula. Okay, so let's look for those. Those were like these guys, right? Yeah, sine of 2u. There's a sine of 2x, but we got sine of 2u. You got cosine of 2u here. So probably gonna have to use those double angle ones. In fact, I think, you know what I noticed right off the bat? See these 2's? I think I want to factor that out. It's all squared. So I'm going to factor out like a 4 basically. But yeah, I just factored that out because I could divide by 4 on both sides and kind of eliminate that right off the bat. This is all squared. Okay, but it equals 1 now. I divided the 4 over 4 divided by 4 is 1. All right. Let's look at these identities. I think, is this 80? Is this the one that we looked at already? No, this is not the same one. Okay, it just looked similar to that one. What if I distribute? See those identities with the 2x, 2u, whatever. I could put those inside, but this is all squared, right?
Yeah.
So do I want to use those identities first and then distribute everything, or do I want to distribute first and then use the identities? Like, what order would you guys prefer?
Which one's easier?
Personally, I think I would distribute first. Here's why I think though, because look at how much longer it gets. Do I really want to distribute and multiply a bunch of stuff together when I have bigger expressions to multiply together? I think I'd rather multiply my smaller expressions. I'd do my distributing on the smaller guys and then do my identities. Yeah, let's see if it works here. I'm gonna do, if I distribute this, I get a sine squared of 2x plus 2 sine 2x cosine 2x, and then plus cosine squared. Where's that? Cosine squared of 2x. All right, that all equals 1. Okay. Ooh, do you guys see any other identities in this that we might like? What's sine squared plus cosine squared? 1? It usually says sine squared of x plus cosine squared of x, right? Equals 1. These have 2 x's, but they both have the same angle. They both have the same, they're both 2x. Now, if it said, you know, sine squared of 2x plus like a cosine squared of 4x, if they weren't the same angle, I couldn't use that identity. These are both the same angle though, so yeah, shoot, I'm gonna do sine squared plus cosine squared equals 1. I'm gonna turn that into a 1. Yeah. Oh, nice. Okay. So let me write this down real quick. So you're basically subtracting 1 on both sides. Is that what you're doing?
Wait, what turned into a 1?
The stuff I underlined in purple turned into 1 sine squared of 2x plus cosine squared of 2x. That was, if you look at your identity sheet,
Yeah.
that was your Pythagorean identity. Sine squared plus cosine squared equals 1.
Oh,
And they both had to be a u. They both had to be the same angle. In our case, they were both a 2x,
yeah.
but that's fine.
Yeah.
So sine squared plus cosine squared equals 1. So that's why I turned that into a 1.
Okay.
All right. But yeah, if I subtract that 1 over on both sides, maybe I'll come over here. That gives me now 2 sine of 2x cosine of 2x. Come on. Equals 0. Equals 0 now, which the 0 makes things so much easier because that means that all this stuff is multiplied together, right? 0 times whatever is 0. I can set my factors here equal to 0. I could say sine of 2x equals 0. I get a cosine of 2x equals 0. Do I really need to say the number 2 equals 0? Like, does 2 ever equal 0?
No.
No? Okay, so I'm not worried about setting that equal to 0. The stuff with the variables, I set equal to 0. Okay, and I'm thinking let's use the identities now. Because if I use the identities, I think that'll help us solve here. My sine of 2u, I have a sine of 2x, same thing. I'm going to do a 2 sine x cosine x equals 0. Which, let's see, on my unit circle, when do sine and cosine equal 0? Let's see. I think that's, yeah, 4 different points. Yeah, I think so. These 4 points, right?
Yeah.
That's when my sine is 0 or my cosine is 0. Basically when my x or my y is 0 on my unit circle. All right. So that's at like 0, pi halves, pi, 3 pi halves. Okay, those guys. All right, cosine of 2x equals 0. What's our identity for cosine of 2x? You actually have multiple identities. Look at this. I could do the first guy, cosine squared minus sine squared equals, cosine squared minus sine squared. I could do 2 cosine squared minus 1. I could do that one. 1 minus 2 sine squared. Honestly, they should all give me the same answers. You can really pick whichever one you want. Is there one that you guys think would be a little easier? The first one?
Yeah, the cosine squared means.
Really? I don't think that would be easier.
Because you only have points where they're equal.
Oh, because you know your circle, so you know when they're equal to each other. That is true. That is true. Okay, so we can do it that way if you like. Cosine squared of, I have an x instead of a u, but same deal. Minus sine squared of x equals 0. So you're saying add the sine squared over. And you're looking at when your sines and cosines are equal to each other. Which on my unit circle, let's see, my sines and cosines on my x's and y's are equal to each other right here and right here. Here's the problem though. Is that pi fourths, right? That 5 pi fourths. I think I'm missing some points. Can you guys tell what I'm missing? Consider the fact that it's squared, yeah.
Yeah, I was going to say that it's basically
All of the pi fourths. Okay, so like this point right here at 3 pi fourths, that gives me a negative root 2 over 2 and a positive root 2 over 2. But if I square the negative root 2 over 2 and I square the positive root 2 over 2, are they both going to give me the same messy number? I think they do, right? Isn't a negative, like, so consider like negative 5 and positive 5. Negative 5 squared, 25. Positive 5 squared, 25. So the negative and positive squared still give me the same number. They're still equal to each other. So I had to consider these other points as well. 3 pi fourths and 7 pi fourths, even though they're off by a sign, once I square them, they're both positive, so they are actually equal to each other.
Because it's cosine squared.
Yeah, because it's cosine squared and sine squared. If it's just straight up cosine has to equal sine, great. Like the x and y, the cosine and the sine are straight up equal to each other at the pi force and the 5 pi force. But if I'm doing cosine squared has to equal a sine squared, negatives or positives don't matter because negative squared versus positive squared, they're all going to be a positive. So that's why I had to get the 3 pi force and the 7 pi force as well. Okay, so let's see what their answers were. Did they get, let's see, 1, 2, 3, 4, 5, 6, 7, 8. It looks like we had all 8 of these. 2, 3, 4, 5, 6, 7. All right, there we go. That's what we got. Same list of angles that they had. All right, any questions on number 24? Yeah.
I put that in and it's wrong.
Does yours start out with the same numbers in here and everything? So you put in a 0.
The numbers don't actually matter because once you factor them out, they just become 1, which then, well, they become the number, which then gets subtracted.
Well, my answer are the angles.
Yeah,
So we're doing a
that
0, a pi force,
should-
pi
that
halves.
should- That should be the same. So the red numbers don't really do anything.
That's true, they didn't.
So it should be
Yeah.
the same answer no matter what you have.
Mm-hmm. So you put it like separated with commas, 0, pi force, pi halves.
Does it have to be in that order?
I don't think it has to be in that order.
Shouldn't have to.
Let's check that out though. I think we are kind of running out of time here. So I don't think I could start another one. But we can pick it up. Like I said, I'll see you guys on Monday, right? Actually, I'll probably not see all of you guys. A bunch of you guys are going to go into the other class. But regardless, we're all doing the same stuff. So
So this,
they might actually have a different review. We'll see.
since they're a lesson behind, and this review is due like Monday,